between road and muddy region. The prior probability of road and muddy regions are 0.4 and 0.6 respectively. The robot extracts a texture feature metric called as say X to distinguish between road and mud. Now it is noted that the road and mud features are normally distributed with mean, that is mu, equal to 10, and this variance is 1. Then for this mud it is 12 and 3 respectively. If mud is classified as road, the loss is 1000 rupees, and if the road is classified as mud, the loss is 10 rupees, and no loss for correct decision. Now if the current feature value coming from sensor is 11, what is the best decision? That is the question. So you have to decide whether this is road or mud. So we have discussed yesterday what are different losses. I hope you can recall. What is lambda 11? Lambda 11 stands for the alpha 1 decision given that true state or true class is omega 1. Okay, alpha 1 is your decision, and you are taking this decision when the actual input sample is belonging to omega 1. So alpha 1 relates to omega 1 decision. So omega 1 is your decision and true state is also omega 1, then there is no loss. Similarly, when you take a decision omega 2 and you have a sample which is from omega 2, so there is no loss. But you take omega 1 decision and you have omega 2 as your input, then you have a loss of 1000 rupees. And if you take omega 2 as your decision when the true state is omega 1, then you have 10 rupees loss. So we have to now solve this problem using yesterday's derivation. So road prior, these are called prior probabilities. The probability of appearing road is 0.4 and probability of appearing mud is 0.6. Now these are the likelihoods of road and mud. Okay, so what it means, it is the distribution of features of road. The features of road and features of mud, they are distributed normally as it is given to us. If I plot that, you will see this is the plot for omega 1, that is your road, and this is the plot for omega 2, that is the mud. So this is mud and this is road. What is mean value? And this is x-axis, which is the feature x. Okay, so feature x is ranging from some minimum value, say here, and maximum value is here. Okay, so this is minimum and this is some maximum. It depends on the surface of your traveling. That is, if you are traveling on road, it is moving around say 10, it is in the range of 10, that is mean value is 10. And when you travel through mud, it is of the order of 12, or mean value is 12. Okay, so depending on what I receive, I have to decide whether this is mud or road. Now given to me is that x test is equal to 11. Okay, so 11 is standing over here. Then I have to say whether I am standing on mud or I am standing on road. So that is the question. And you know that there is a penalty of 1000 rupees that is given in our problem. There is a penalty if mud is classified as road. Since the robot gets damaged when it travels through mud, so I can bear a wrong decision for a road. That is, if there is a road and if I call it as mud and do some action, that may cost me 10 rupees. But if I take a decision for mud as road and if I travel, then it will cost me 1000 rupees. So I don't want to travel on mud. So that is my binding. So I'm not interested in traveling in mud, and I can bear the cost of 10 rupees for taking a wrong decision, that is classifying road as mud. So that is also a costly decision, but compared to 1000 rupees, 10 rupees is less, so I am able to bear this much amount. Okay, so taking into account this fact that I can bear 10 rupees but I cannot bear 1000 rupees, I have to solve this problem. Okay, so as per our earlier discussion, this lambda 11 is equal to lambda 22 equal to 0. So this is given to us. Lambda 12 is 1000 and lambda 21 is 10. Now if x is equal to 11, decide the class. Now we know that from our previous discussion, we will go with omega 1 as the decision when this ratio probability of x given omega 1 to probability of x given omega 2, if this ratio is greater than this threshold. Okay, if this ratio is greater than this threshold, then I will decide that this is omega 1. In this case, omega 1 is rho. If it is less, if this is less, then my decision will be mud. Okay, so this formula incorporates all our things. That is, we are taking into account losses and the probabilities. Okay, so this is what we want. So this is a joint thing where I take into account probability and the losses. We are just not interested in reducing probability of error. We are also interested in reducing losses. Okay, so this is a joint thing. Earlier, simple Bayes concentrates on only probability of error. Now let us see how we can proceed. So what I do is I just substitute the values of the losses that are given to us. So I know that it is 1000 for lambda 12 minus 0, then 10 for lambda 21 minus 0, and these are the priors already known to us. Okay, so this is the theta. Okay, now this is the theta, and from left hand side we are now writing the formula for normal distribution. We have assumed that our features are normally distributed, so I am just writing here the formula for normal distribution for the numerator as well as denominator. So if you recall from the previous slides, I have discussed this normal distribution already. So I'm just writing the formula and substituting the proper values into this. Okay, so if you don't recall, then I have to search backside. I hope you can note down this and then you can check with actual formula what I'm doing here. Okay, the formula is same. It is 1 by twice squared to the power half, okay, into this e to the power minus half into x minus mu divided by whole square. Okay, so you can simply substitute the values and then solve for like this. Okay, so go on solving this. So on left hand side you have this equation in the form of exponential, and then right hand side is 150, which is a constant. If you keep on solving, you will get this answer as the ratio is 1.92 and right hand side is 150. So decision is mud. Is this right? What we started with, we want this ratio to be greater than this theta t, but what we are obtaining is ratio is less than theta t. Since ratio is less than theta t, our decision is now omega 2. Otherwise it would have been omega 1. Okay. So if now you try this at home later on, if x is equal to 9.5, what is your decision? Road or mud? Now based on this Bayesian decisions, we can formulate a kind of a network which takes the action based on Bayes. So this is called as classifiers using discriminant function. What is meaning of discrimination? Discrimination means differentiating between classes. Say class 1 is differentiated with respect to class 2. So this decision boundary which separates two classes is called as discriminant line or discriminant, I can say, function kind of a thing. So what I mean by function here is, I want a system like this, that this is suppose my input x and this is suppose a function. Let us call this as g1x, and let us call this second function as suppose g2x. Okay, and they are producing their own outputs, and this is given to a max selector. The idea is very simple. You have the input here which goes to these two functions. You will calculate g1x, then you will calculate g2x. Then whichever is max, whichever value is max, index of that function is your class. Okay, so if g1x is greater than g2x, you will say that my input x belongs to class 1. If g1x is less than g2x, then you will say that x belongs to class 2. Okay, so I can extend this concept for c number of classes or many classes. So what is done here is the input feature vector x, this complete thing is x, and these are individual elements in that x. So x I can write as a vector like this: x1, x2, x3, and so on up to xd. So these connections which are shown here, they are the input nodes of this system. So every, say, node here, say for g1x, I am receiving complete x. For second also I am receiving complete x, and for rest also I am receiving complete x. And this x will be given to this function g1x, g2x, and so on up to gcx. So they will produce some values here, different values here, and as a classifier you will find out which one is max. Okay, so then you declare that particular node number as your output. Say if this is the winner, the node 2 is winner, then output is class 2. If node 3 somewhere here is a winner, then you will declare class as class 3. So like that we can differentiate or discriminate different classes. Okay, so this is the key concept. Now question is, what is my G1x, what is my G2x, what should be G3x, and so on up to what should be GCX. I don't know these values. Concept is clear. I will design a function which tells me if the input belongs to that particular class. It will have the highest output if input belongs to that particular class. So that is the concept. But thing is that how to decide or how to find out G1x, G2x and so on up to GCX. So for this purpose, we are going to take help of Bayes again. Okay, so based on the Bayes, we will find out all these functions. So in tomorrow's class, we will discuss this. Right now, I will stop because there are only 2 minutes for your exam. So you can start logging there and start your exams.